Good afternoon. Here the topic is work done for variable force. You can see the topic, work done for variable force. You know the procedure of calculation for work done. If force is known, if displacement is known, then just the product of force and displacement will give you the work done. Okay. So if be the force and S be the displacement, then what is the work done from here? Then work done is equal to F into S. This is known to you. Okay. And suppose these are given in only magnitudes are given. Okay. Suppose force is given as a vector, displacement is also given as a vector. Suppose force is given this way. This is force vector and this is displacement vector. Then in that case, what is the work done? In that case, we know that work done is equal to the product of F and S. Dot product. Product means here dot product. Okay. This is the dot product of F and S. Okay. And you know what is the result? Result is magnitude of F into magnitude of S multiplied by the cosine on the angle between them. Them means what? They means here force and displacement. Okay. So that is cos theta. And if force and displacement are in the same direction, in that case theta becomes 0. So cos 0 will be is equal to 1. Okay. So the result will be only magnitude of F into magnitude of S. But if the directions are different, in that case work done will be like this, F into S. I am giving you one example. Suppose if you take one inclined plane like this. Okay, this is one inclined plane and inclination of the inclined plane is denoted by theta. Say, inclination of the inclined plane is denoted by theta. And suppose one block is kept over here on the inclined plane, one block is kept over the inclined plane, and suppose there is no friction acting between the block and the surface of the inclined plane. Frictional force is absent. Okay. So if you consider such case, so in that case, since friction is absent, obviously this block will start moving in the downward direction along the inclined plane, not in the vertical downward direction, because there is presence of inclined plane. So what will happen? So this block will move in this direction. Okay. In this direction the block will move. Say this is the starting point. This dot, okay. I am showing this way. Larger dot. Okay. So finally the block reaches here, somewhere here. Okay. Then so say point 1 denotes the starting point, and here this is the final position of the block. Say, so the corresponding point of this is what? This one. This is the corresponding point. Say this point is denoted by 2. Okay. So question is here, what is the work done in that case? So force is acting in this direction and displacement is also in this direction. But actually force is not acting in this direction. Force is acting in the vertically downward direction. That is force due to gravity. Gravitational acceleration is present. Okay. So due to that, the force is acting actually in the vertically downward direction. But if you take component of that force in this direction, okay, so that force multiplied by the displacement. Suppose the displacement is denoted by here S suffix 1 2, from 1 to 2, S suffix 1 2. Okay. So that is this is the displacement, S suffix 1 2. And suppose in this direction the force is denoted by F suffix 1 2. F suffix 1 2 is the force in this direction. Then F 1 2 into S 1 2, this is the work done for 1 2. 1 2, this is not 12. Okay, point 1 to point 2. W 1 2. or in between 1 and 2 you can put one dash also to represent from 1 to 2. In between 1 and 2 you just put one dash to represent from point 1 to point 2. So W12, this is the work done for the displacement from point 1 to point 2, and that is equal to F12. F12 is the force along the inclined plane multiplied by the displacement S12. So S12, this can be directly measured. Okay, by using any scale, you can directly measure the displacement S12 along the inclined plane. Now question is, what is F12? Okay, that is the question. Suppose mass of this block, this is M. Mass of the block is M. Then what is the weight of the block? That is equal to mg. That will be acting in the vertically downward direction. That is the weight. Now you have to resolve this weight mg into two components. One along the inclined plane and another perpendicular to the inclined plane. If you look at this problem carefully, then you will find that if this angle is theta, then this angle is also theta. Okay, so in that case, component of mg in this direction is mg cos theta, and in this direction it is mg sin theta. So this component is what? Mg sin theta. Right? Mg sin theta. So here F12 is how much? Mg sin theta. So F12, this is equal to mg sin theta. So what is the result here? So this is equal to mg sin theta, okay, into S12, the distance. So this is the result. Okay, this is the result, mg sin theta into S12. So this way we can calculate work done for the given problem. Now suppose, so here what we have done, just we have multiplied the force by the displacement, because here force is not changing. From this point to this point, force remains constant. Force remains constant, it is not changing. The magnitude of the force remains constant, as well as the direction also remains constant here. Okay, means the vector force, the force vector, it remains constant throughout the journey or throughout the path or throughout point 1 to point 2. But suppose if we take another example where force is varying. Say force is given as a function of displacement. Means when displacement changes, say we are taking this problem. This is a straight line. The direction, say this is x. Okay, this direction is x, this is horizontal, and this point is the origin denoted by 0, and here one block is kept over here, not over here, starting point. So this way I am showing you the starting point. This is the starting point, okay, and it is moving in this direction, means along x-axis. This is moving, and force, this is given. The force, this is given, the magnitude of the force is given as a function of x. Say F is equal to x square plus 2. And suppose somewhere here, the point, here x is equal to how much? Here x is equal to 0. Here, at the origin, okay. And here x is equal to how much? Here, say x is equal to 4 meter. X is equal to 4 meter. So question is, what is the work done in this case? So what is the displacement? You can easily see displacement is from this point to this point, which is equal to 4 meter. So the displacement is 4 meter. But you can see force is not a constant. It depends upon x. X is what? It is displacement. That means here force is dependent upon x. Force is continuously varying. If you put x is equal to 0, you will get F is equal to 2. If you put x is equal to 1, then you will get what? 1 square plus 2, that is 3. F is equal to 3. If you put x is equal to 2, then you will get what? 2 square plus 2, that is 6. So you can see that force is continuously varying from this origin up to this point. Force is continuously varying. So you cannot multiply directly force with displacement to get the work done. So what you need to do, you take any point, say this point on this line. Can you see this point on this line? Say this point is at a distance of x from the origin, and just adjacent to this point you take another point, say this point. Say first point is denoted by A, second point is denoted by B, and the distance between A and B, the point A and B, the distance between them is very small. Okay, say that small distance is denoted by dx. In between the points A and B, the distance is very small, it is denoted by dx. Okay, this is infinitesimally small quantity. So, what is force here at point A? That will be denoted by this expression. So, force at point A, this is denoted by x square plus 2, because location is x and f is given as a function of x. And at location B, what is the distance from origin of location B? It is x plus dx, right? So at point B, what is the force? That is equal to x plus dx whole square plus 2. Okay, so since x is a finite quantity and dx is infinitesimally small quantity, okay, so in that case, if you add x with dx, in that case, square of x and square of x plus dx square, there will be actually no difference. Means difference is of course there, but that difference is very small. That can be neglected at ease. So you can see, so square of x and square of x plus dx, actually there is no difference. So since there is no difference and the other part, this plus 2, they are same. So in that case, what will happen? Difference between FA and FB will be 0. Means force at A is equal to force at B. So for the displacement from point A to point B, we can consider the force to be this much, x square plus 2. This is the force and displacement is how much? That is dx. So work done, I am writing this way, W A dash B. This is equal to FA into dx, and FA is what? This is x square plus 2. So this into dx. This is work done for point A to point B. Then what is the total work done from point 0 to up to point 4? So in that case, total work done, I am writing this way, W suffix total. That will be equal to what? That will be equal to integration of this. Summation of this, that means integration of this expression. So that will be equal to this, x square plus 2 dx. And what is the limit? X varies from where to where? X varies from 0 to 4. So x varies from 0 to 4. So what is the result? You know, integration of this is nothing but x cube by 3. And 2 is there, so here you will get 2x. Right? So now you just put the limits. Okay. So after putting limits, what you will get? Here you will get 4 cube. Means 64. 64 by 3 and 2 into 4, that is 8. Sorry. 2 into 4, that is 8. Yeah, 2 into 4, that is 8. And if you put 0, you will get absolutely 0. So what is the result? 64 plus 24 divided by 3. Okay. So 4, 4, 8, 6 to 8, 88 by 3 Newton. Just use your calculator to get the answer in terms of decimal. Okay. 88 by 3 Newton. Am I right? So this was the solution of the procedure. So this is what? This is variable force. This is not a constant force. This is a variable force. And it varies along x. It is dependent upon x. Again, force may be given in terms of time also. Force as a function of time. So whatever be the case, If force is a variable, in that case you need to do integration. Okay, in that case you need to do integration to get the desired result. Okay, so this was all about work done for variable forces. Okay, so this was a topic on work, power and energy from class 10 plus 2 level. If you like my video, please subscribe my channel. Okay, thank you for watching this video. Have a nice day.